problem on grouping also. Grouping, right? This is the example. I think you know this one because earlier on I asked you already. You know how to solve this type of question. Okay, never mind. We just say uh, 4 cubes and 4 cuboids of different colors in a row. So the cubes, they are not identical. If identical, you have to divide by 4 factorial, right? So the 4 cubes, they are different because they look different because they have different colors. Also, the 4 cuboids, they all look different, right? So the number of ways to arrange this object if there is no condition imposed. No condition imposed means what, Means 4 cubes, 4 cuboid, altogether there are 8 objects. How many ways of arranging the 8 objects? So the number of ways of arranging the 8 objects, 8 factorial, because there's no grouping, there's no identical object, so 8 factorial. Now the first question here, all the cubes must be placed next to each other. This means that the cube all inside one group. Cube inside one group means cube, cuboid, 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 cuboid. Or cuboid, then cube, cuboid, 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 like that. So it will be like this. Like Jia Yan just now told me already. She knows how many objects are there. 1, 2, 3, 4, 5. Altogether 5 objects. One group and 4 separate objects. So altogether 5 objects. So 1, 2, 3, 4, 5. So how many external arrangement? 5 objects. External arrangement will be 5 factorial, right? However, the 4 cubes they can arrange among themselves. So the internal arrangement of the cubes, 4 factorial. Because inside here also they can arrange white, blue, pink, orange, pink, blue, white, orange, and so on. They can arrange among themselves. So how many ways altogether? 5 factorial times 4 factorial. That is 2880. 2880. Now I want to ask you my own question. Find the number of ways if they are grouped according to cubes and cuboid. It means what? It means that cube in one group, cuboid in another group. How many ways are there? Now there are 2 groups. The cuboid are no longer separated. The cuboid grouped together as one group. Right. So object inside the cube, 4 factorial, internal arrangement. Inside the cuboid group, also 4 factorial. That is the internal arrangement. Then within the group, we can be cube, cuboid, cuboid, cube. So altogether, there are 2 groups. So 2 factorial. 2 factorial, right? So internal arrangement of cubes, 4 factorial. Internal arrangement of cuboid, 4 factorial. External arrangement of the groups, 2 factorial. So total number of ways, 2 factorial times 4 factorial times 4 factorial. So answer is 1152.